Good morning. My name is Mark Loewes. I'm a trainer for Shearer and Partner Supply. Thank you for being with us today. Today we're going to discuss A2L refrigerants. What does it mean to you as a contractor? How do you plan to work with it in the future, and how does it change my business? Now, A2Ls is here. There's actually a competitor out there now that has already made the transition from R410 to R454. My understanding is, equipment's going in perfectly fine, and there's no concerns and problems with it. For us at Partners and Shearer Supply, we've decided to put off the transition to R454 for a price competitive reason. So we will be stocking R410 equipment. We're hoping through March of next year, but that all depends on how much of our POs are filled from our vendors. So if all our POs are full, we should have product in stock for you till about March of next year, which will then make the transition to the new refrigerant. But you're going to have your hands on it probably sooner than that. So we wanted to make sure that you understood what the refrigerant is. How does it work for me? Later in this series, later in the calendar year, we'll be offering a installation class specific to your brand. And then a little later after that, probably around the first of the year, we'll start troubleshooting classes specifically to the brand of equipment that you represent. So again, good morning and welcome to the A2L class. This class should be about an hour long. If you have questions or comments, please put it in the Q&A. The chat feature is closed this morning, but the Q&A is open and I'll try to keep an eye on it. So why a refrigerant change? Again, if you've been around for a while, we've already gone from R22 to R410, and now we're going from R410 to a lower, what they're calling GWP refrigerant. So the transition from R22 to R410 back in 2010 was, at that time, they were measuring ozone depletion. How much of an impact did the refrigerant have on ozone? So back then, they made a decision that R410 had less of an impact on ozone, and that's why we made the change from R22 to R410. Well, nowadays, they're measuring that impact differently. They're measuring that impact with GWP, which means global warming potential. Now, you can Google it and get a specific definition for it if that's what you want. But the bottom line is the higher the number, the more impact it has on our environment. So by having refrigerants with a lower number, honestly, is like the green strategy of the refrigerant. So GWP for after January 1st of 2025, all new equipment has to have a GWP below 700. R410 is 2088. And then we'll see specifically what 32 and R454 are, but we need to lower that GWP number to keep a greener economy or a greener environment. So if you look at, again, R410A is 2088 GWP. The new rule as of January 1st means that refrigerant has to be below 700. R32 comes in at 675 and R454 466. So there's two refrigerants that fall below that 700 ceiling of low GWP, and those are the two refrigerants that we'll be seeing in our market of residential and light commercial. One of the things I want to point out, right, because we're always on the move and the industry is always changing, that in 2034, right, it sounds like a lifetime away, but it's less than 10 years. We actually are already slated to change that refrigerant again. And even the new refrigerants are calling for natural refrigerants. There's really only two refrigerants that fall into that category today, and that is either propane or CO2 systems. Now, we know at propane, right, we have the ability to even carry flame and a lot more flame with propane. And then even with CO2, the operating pressures with CO2 is traditionally above 1200 PSI. So what they're looking at for this style of refrigerant is what they call a monoblock condenser. That's not what today's class is about, so I won't spend a whole lot of time on it. But basically, the whole refrigeration process would happen outside, probably transfer that energy to a liquid like water, maybe with a little antifreeze in it. But that water fluid would then come into the house and actually run that through an evaporator coil inside your house to absorb that heat. But that's probably where the industry's headed. And again, we've got 10 years yet to work our way into that. So when we look at R410 refrigerant, what we've been using for quite a while now, R410 is actually half R32 refrigerant. Well, I know you're going to ask yourself, well, if it was half R32, why is this also not a flammable refrigerant? And that would be because the other half of R410 is R125. R125 is actually a natural fire suppressant. So when you mixed R125 with R32 to make R410A, there was no fire potential in that refrigerant. Now with R454, we've actually increased the quantity of R32 in the mixture to 69%. And the other refrigerant is made up of 31% R1234YF. 1234YF is traditionally what you find in your newer automobiles. Both of those R32 and R1234YF are low flammability refrigerants, and hence that's why the R454 is also a low flammability refrigerant. Now let's talk about that A2L number. Where does it come from? Well, what they've done is they've safety coded refrigerants. Now, if you've been in the residential light commercial market for most of your career, then all you've ever dealt with is A1 refrigerants, lower toxicity and no ability to propagate and carry flame. So R22, R407C, R410, anything that we've been dealing with in the residential light commercial market has always been an A1 refrigerant. Again, lower toxicity, and it doesn't have the ability to carry flame. Now, if you've been in the refrigeration market for a while, where you're doing walk-in coolers or you're doing glass cases and stuff like that, they've been in the flammable refrigerant market for a while with A2 and A3 refrigerants. Now, if you go from A1 to A2, it becomes a more flammable refrigerant. Now, again, from A2 to A3, it becomes even more flammable. The amount of flame that it can carry, the amount of energy required to ignite it is less, so it becomes a more dangerous refrigerant. So one of the refrigerants we've had in that market already is R290, which is propane. Now, R290 is actually a great refrigerant. It works well for transferring temperature and all that other stuff. Matter of fact, your refrigerator at home probably has R290 in it, but it has such a small amount of it that even if it were to spring a leak, it wouldn't be enough of a content to cause a problem in your home. So anyhow, what they did is when this new refrigerant came out, now when I say new, A2Ls, they've actually been around for 10 years. They've been in other markets and just not the residential like commercial market. Matter of fact, R32 has been in Europe now for almost a decade. So it's actually been around for quite a while. But when they came out with these refrigerants, they weren't flammable enough to be A2s, but they still did propagate flame, which made it, they weren't an A1. So they created this new banding of A2L, which falls in between A1 and A2. Now let's talk specifically in comparisons about the flammability of this refrigerant. So if you look at the chart in front of you, I've got boxes around R454 and then circles around R290, which is propane. The first one I want to go down to is that LFL. That's the low flammability limit. That low flammability limit's definition is how much refrigerant blend do I have to have with oxygen to make it flammable? So if I look at the R290, the one with the circle on it, it says 2.1%. Means I only need 2% propane in that air for it to be flammable, a small portion. Now for R454, I need at least 11.8% of refrigerant to air mixture to make this flammable. Okay. The next graph down, if we look at minimum ignition energy, this is measured in megajoules. Now, I didn't know what megajoules was, so I had to Google it. They gave me a math calculation that explained how to measure a megajoule, but it still didn't really tell me in practical terms what kind of power is that. I'll show you that in just a second. But propane needs 0.25 megajoules of power for it to ignite. R454 needs roughly between 100 and 300 megajoules of power for it to ignite. So it needs a great deal more energy for it to ignite. A 24-volt transformer spark isn't enough energy to ignite R454 refrigerant. Also, the amount of BTUs that refrigerant carries, R290 or propane, 1 pound of it will make about approximately 19,000 BTUs of capacity out of it. 1 pound of R454 will make roughly 4,000 BTUs out of it. So again, much smaller kind of, I hate to use the word bang for the buck, but we're not talking about something that carries the energy of propane here. Number one, it needs a lot higher mixture for it to have any kind of combustibility. It needs a great deal of energy for it to even ignite. And even once it ignites, if you have that high energy source, once that high energy source is removed, the flame goes immediately out. It needs that energy source the whole time it's burning, or it will snuff itself out. So I'm kind of a basic person. I need to understand when it talks about the flame pattern. So flame pattern for R454 is measured in 5.2 centimeters a second. That's how fast the flame will move under proper mixture and proper energy source to ignite it. Now, 5.2 centimeters a second, I had a look. Google had a chart where I could convert that to miles per hour. And in miles per hour, in 5.2 centimeters a second, is a little more than 1/10 of a mile per hour. And you can see my little meatheads, right? That's about as fast as they move, right? But if we go to propane, propane moves at 46 centimeters a second once it's ignited, which is over a mile an hour. So we're talking about something, even with R454, that the flame moves very, very slow on, not like propane where you get that big whoosh when it's ignited. Also, I wanted to take a bigger dive into that megajoules of power because, right, I need to understand what a megajoule is. So again, Google has a little conversion chart where I can take they said between 100 and 300 megajoules of power. And where that changes is in that mixture of refrigerants. So I just took it in the middle, roughly in the middle of 150 megajoules of power. I converted that to kilowatts. And you guys know what a kilowatt heater is, right? You buy them all the time for your air handlers. This one, 150 megajoules of power is equivalent to a 41 kW heater, right? A great deal of electricity and energy or power would need to be moved for that to happen. Now, your spark plug on your car, just as an example, is roughly 50 megajoules of power. So I would need 3 times the spark of the spark plug on my car to ignite R454 refrigerant. Now, if I look at propane, propane needs just, again, 0.25 millijoules of power, right? That little Bezos switch that's on my grill, and I don't know about your grill, but mine is covered in grease and dirt and all that other stuff. It doesn't, that itty bitty little spark that come out there is enough to light my propane, but it's not anywhere near the power source needed to ignite R454. Here's a video that was actually taken at the Opteon lab. See that little blue ball going up the center of the glass? It'll happen a couple more times. But this is actually at the refrigerant lab for Opteon. What they did is they made a perfect mixture of refrigerant to air inside that bottle at the bottom. There goes the blue ball again. That's the amount of energy and speed that R454 ignites in, right? We're not talking about something that's that's a glass tube in there. We're not blowing that glass tube apart, right? There you go for the last time. But that's how fast the flame moves when it's ignited with the correct power source. Also with equipment, it doesn't matter by brand. Every brand of equipment, when it's an R454 system, they're going to have tags or some markings on the service ports to let you know that it has the A2L refrigerant in it. Now, this happens to be the Trane American Standard brand. They're using these little red discs at all the service ports. So any place that you would hook up your gauges, they're going to have this tab to it. Armstrong Duquesne's going to have similar style tag, but it's going to be square. So any place that you can hook up a service port, it's going to have that red square plastic tab to it to signify. Now, somebody from a class that I did yesterday here in Knoxville shared with me that they put in a Daikin system, and Daikin actually painted their service caps red. She had also said they were longer than usual, which I hadn't seen, but the length of the cap was longer, and that they were all indicated by being coated in red. But anyhow, that's how they're going to signify to you that that system has R454 refrigerant in it, or even R32. There'll also be quite a bit more stickers on the equipment. Right, as we want to make sure that people are safe and that people are taking extra caution, right? That's just the way society is today. We're probably adding 3 more stickers to our indoor evaporator coil, if that's the air handler. We're adding a few more stickers to our, our outside unit. So you'll see the warning labels on there. And guys, technology's changing, guys and gals. Technology's changing. I'd always encourage you to make sure you know what you're working on before you take the covers off this equipment. If it's inverter driven, right, we have the potential of shocking you if we don't have a good earth ground on that system. So always know what you're working on. We want you to go home at the end of the day. Also, as part of the new R454 or R32 package, the systems will actually have a sticker. The outdoor unit will have a sticker on it when it's a split system asking for total refrigerant charge. In one line, you would add what the data plate came pre-charged from the factory. Any additional charge you would add goes underneath, and then a total with your dealer name and phone number. That way, that system is identified with exactly how much refrigerant it has in it. Also, I don't know how many of you have noticed, but our refrigerant bottles have had relief valves on them for quite some time. It's for our R410 or R22 refrigerant, it was a disc towards the top of the handle of the tank itself. Now, I've been traveling all over the South, everywhere from the panhandle of Texas into Georgia and Florida. And, I've only had 3 people tell me they've ever seen this disc pop. But most of the time, I believe all 3 situations, they didn't even hear it pop, and they just came to their truck and noticed it was popped. So when the tank gets hot enough that the pressure inside of it, starts to elevate to an unsafe level, and really what they're trying to do is make sure that that whole tank doesn't turn into shrapnel if it were to explode from pressure. So they actually put this rupture disc in it that allows this disc to actually relieve the refrigerant before the tank itself becomes dangerous. So on R22 and R410 tanks, or even your R407, that's a one-time disc, meaning that once it pops, it relieves the entire contents of the tank, and it's empty, and you just throw it in the trash and you're done with it. On A2L refrigerants, so R32 and R454, that relief valve is actually going to change to a spring-loaded relief valve. And what that's going to allow the system, that tank, to do is if it does get too high in pressure, it will actually relieve some of the refrigerant so that the pressure drops in the tank and that valve will reseat so that you don't lose the entire contents of that tank. What does that mean to you as a service technician or installer? You just want to make sure that your tanks are, especially these new A2L tanks, are upright in your truck, or that relief valve is upright in your truck. So if you're driving around and you've got a tank that you don't use a rack in, I make sure that I keep the box or have a milk crate that I can set that tank inside of and make sure that my relief valve is at the top of that tank. If I am using a rack in the tank that puts my bottle in the horizontal position, I want that relief valve, again, at the top of the tank. This way, if it does vent, I'm venting gas instead of liquid refrigerant. We've got a question in the Q&A, just a moment. Are access ports still a 1/4 inch flare? Yes, they are. Access ports on the unit have not changed. They're exactly the same as they are today. The refrigerant tank has changed, and we'll talk about that in just a minute. So by Department of Transportation rule, a typical service van. Now, this is an enclosed van that they're talking about, not a pickup truck, not a delivery vehicle. This is an enclosed service van. You are allowed 6 cans of refrigerant inside that truck. Now, let me clarify, 6 cans of flammable refrigerant inside that truck. That's by DOT rule. Now, what that says, or what that means to me, is I can have a can of R32, right? Because if you're going to be a service person, you're going to need to be able to service R32 systems and R454 systems. So I'm going to have a can of R32 and a backup. I'm going to have a can of R454 and backup. And then I'm going to have 2 reclaim tanks because I don't want to mix my refrigerant if I'm reclaiming a system. So that ties up my 6 cans of refrigerant. Now, keep in mind that this 6 can max does not include non-flammable refrigerants. So your R407C, your R22, your R410 does not play into that. All right, this is going to be one of the weird spots, and I won't be able to give you necessarily an answer for this one because a lot of these answers haven't been clearly defined yet by your local code authorities, right? And we're dealing with, I don't know, roughly 9 states or 10 states that we deal business in, and this can change even by city and villages and stuff. So inside the mechanical code, IMC, which every area for the most part uses and sets their own building code off of. They may use 2010 IMC, they may use 2016 IMC. That's International Mechanical Code. But A2L refrigerants have been in that IMC for over 10 years now because, again, they've been in the refrigeration market. So a lot of the requirements are still kind of up in the air. We only have, I believe, 4 states in the entire country that have instituted refrigerant, this A2L refrigerant as part of their residential code. The rest of them haven't even done it yet. They're going to need to get on the ball because this refrigerant is coming at the first of the year. But what I'm going to encourage you to do is if you have a relationship with your local building code, ask them so you know ahead of time when we get to this refrigerant, what standards are they going to follow? What standards are they going to expect? Because part of IMC says that I need protective shielding wherever that line set will penetrate an interior wall. Now, that's a 16-inch steel sleeve when it penetrates a 2x4, right? What if I have an existing home? Am I going to have to open that wall up? There's even portions of the IMC that say that that refrigerant line goes through a chaseway and it's A2L refrigerant. You may need ventilation in that chaseway, right? So you'll need to understand that. I won't be able to, right? There's too many communities out there for me to have that information. This is information that you're going to need to get from your local building department. All of our techniques for using our closing up refrigerant lines are still okay with the new flammable refrigerant or low flammability refrigerant. We can use our brazing. We can also use flare joints, and even mechanical connections, crimp style connections, are even approved for this refrigerant. As a matter of fact, we're actually seeing a lot of the manufacturers are actually wanting these mechanical connections. So there are manufacturers that when they come out with this new refrigerant, that they're actually going to provide stub outs, or your service ports will no longer have that bevel end on it because they're going to be encouraging you to use those mechanical fittings. If you want to get really deep dive into the standards of safety, you could download the ASHRAE manual. It's $100 for the download, and it's a big, thick, sticky manual with a lot of detailed engineer-style information. But if you really want to get into the weeds, that would be your best place to do that. Also, your EPA 608 certification will cover the new refrigerant. There is talk that that may change, but as of today, your EPA 608 will cover the A2L refrigerants. I've got another question, just a moment. What does it do to mix ratio, and is the drum wasted if vented? No, Lionel, the R454 is very similar in the layout of it, in the formula of it, of R410. So you'll even see at the end that you can even top off with this refrigerant stuff. But if you do have a relief of your tank, you can use the rest of the contents of your tank. And again, we don't see that very often where that pop actually happens. But if it were to happen to you, you can still use the remaining contents of that tank. So one of the big safety things that changes with the new refrigerant is we are no longer unbrazing components of that system. So if your service technique, hold on a minute. It says my screen sharing's paused. Why is that? Just a moment. Sorry, just a moment. New share. Come on. I don't know why I did that. Just a second. I'm sorry. Little turkey. All right. Hopefully you can see it again. I'm sorry about that. So one of the big service sides of it, this is nothing to do with installation, right? Because installation, you're starting with a new cleaner system. This is talking about going back as a service procedure on that new A2L refrigerant. one of the things they want to make sure that you have in mind is that you're not unbrazing a TXV or a switchover valve or unbrazing a compressor to remove it from an A2L system. You want to make sure that you're cutting that old component out with a tubing cutter. Now, somebody brought up to me in class just yesterday. So what about a switchover valve, right? We're going to need some small tubing cutters, or we're going to need some good components to be able to cut out a switchover valve, because those stub outs are so close together. I get it. I understand. Maybe you'll have to cut it farther down and build that part back. I don't know how that practice will work for you, but you're not going to want to unbraze that system. With the acetylene torch that you're doing, or that oxygen acetylene torch, if I put a flame to that and I have refrigerant released from oil, that could start on fire for me. So I want to make sure that I'm cutting my components loose. This talks about some of that pipe protection, again, as part of the IMC. Again, my recommendation is to always go back to your local building code and look at how they're going to address it. Now, when it comes to servicing systems, so one, we need gauges that are good for R32 and R454. Now, equipment manufacturers and industry best practices says I need a set of gauges for each refrigerant that I work on. Right, that gets to be pretty expensive, but you definitely don't want to be blending refrigerants. R32 doesn't work at the same pressures as R454. And even though R454 is very similar in the PT chart of R410, we, again, don't want to mix refrigerants. Will somebody do it? Probably, and they can tell us how it works. But the factory definitely doesn't recommend it. The industry definitely doesn't recommend it. So you're going to need gauges that will do R32 and R454. The reclaimer you're using also will have to be a brushless DC spark-proof motor. That's quite the mouthful. But what we want to make sure is that the motor being used on a reclaimer doesn't have the ability to carry a spark. Now, the good news is, in this industry for the last 5 years or more, a lot of these reclaimers already have that. So what you want to do is look at the reclaimer that you have and make sure that it has a brushless spark-proof DC motor on that reclaimer. Now, it's also recommended that your vacuum pump be brushless and DC as well. But if you think about when you're using that vacuum pump, that system is completely open and void of refrigerant, and you're just starting from a fresh system. So you shouldn't be coming in contact with that refrigerant with that vacuum pump. Now, somebody had asked about the threads on the service or on the unit itself. The threads on the unit are exactly the same. The threads on your reclaim tank are exactly the same. So what they did is on the jugs of refrigerant, this would be R32 and R454, the jugs of refrigerant, they're treating almost like oil field. If anybody's got any oil field experience, anything that was flammable out in the oil field industry had a red stripe on it and had backwards threads. It's being used the same adaptation here in our refrigerant. So the threads on the Freon tank are backwards. They're a 1/4 inch flare, but they're reverse or counterclockwise thread. So we're going to sell an adapter that you can use your normal hoses and gauges and just have an adapter to the tank itself. Repairs, as I mentioned, we're cutting the components out. So what I want to do is reclaim all my refrigerant. I want to then, before I cut the component out, I actually want to purge the system with nitrogen. So typical system would be a 2-minute purge. When you're talking about a residential split system or a residential package unit, once I've reclaimed that refrigerant, I'm going to flow nitrogen through it for 2 minutes. Any trapped refrigerant or any refrigerant that's trapped in that oil, I have the ability now with that nitrogen to push it out so it's no longer flammable. And then I'm going to use my tubing cutter to cut that either failed TXV, compressor, or switchover valve, or whatever component out of that system before I put it back together. Now, if I'm either installing a new system or I've opened that system to make a repair, when I'm done, we need to pressure test that system to 600 PSI. That needs to hold what not code, what the manufacturer's recommendation is a 1-hour hold of 600 PSI. And then we need to pull that system down to a 350 micron to make sure that that system is sealed and tight. We have some questions. Let me jump into that. Will refrigeration line sets need to be changed out? Probably not. No. So all equipment brands have a little bit of a change. Well, except for Armstrong and Duquesne. Armstrong and Duquesne doesn't have any really changes in their line sets. American Standard does. Now, what American Standard says is that for anything to meet its AHRI, they're actually using 5/16 liquid lines. Now, can I use an existing 3/8 line? Yes, it's pre-approved with 3/8 liquid lines. Now, with some of our variable speed product, the length of those line sets will be reducing. Currently, it's 150 feet, which is super long, but with our new variable speed products, some of those may drop into the 80 feet range. So I always say when you're ready to put your new system in, if it's a normal line set, you're fine. But again, my philosophy is, and I think the manufacturer's philosophy is, our vapor lines are better off smaller than bigger. Bigger refrigerant lines, that oil sits out in the line set, and I don't have enough velocity in that refrigerant to push it back to keep my compressor safe. So the little BTU loss that I have with a smaller line set will keep my compressor safe and the durability of that compressor a lot better. So anyhow, let's move on. If you are a contractor that's going to be putting in an A2L refrigerant in somebody's home, and the space that indoor piece of equipment is being installed is in the same space as a residential water heater, gas burning water heater, that water heater will need to be FVI, flammable vapor ignition resistant. Now, basically, any water heater residential that was built after January of 2003 already has that FVIR built into it. But if you see an old water heater on it, you're going to have to include with that homeowner that they get that updated. Now, if that's not your business, that's fine. I certainly understand that. But your install will need to be contingent on that water heater being updated. So handling R410 and R454 are very similar. Topping off a system is fine. If you need to do a gas and go during the summertime, you're fine to do that. If you need to gas and go a couple times, or that system's lost the majority of its refrigerant, obviously, just right for best practices, we want to repair those leaks and then charge it back up. And if you've done a couple or more gas and goes, again, for just good practice, we should be fixing that leak for that homeowner and charging it with new refrigerant. So let's get into the mitigation control. I've sat through multiple brands presentations of A2L, and it looks like everybody's on pretty much the same path as it comes to mitigation. So mitigation is, how do they measure that refrigerant and make that system safe if there's a leak? So what everybody is doing that I've seen, now when I mean everybody, all the ones, I probably sat through half a dozen manufacturers, and they're all running the same kind of plan. They're going to have a sensor that sits down in the evaporator condensate drain pan or near the condensate drain pan of the evaporator. That sensor will detect a refrigerant leak. Now, I've heard different percentages, so there might be different by brand, but they want to see if that system starts to pool refrigerant above or getting near that 12% mixture of refrigerant to air. Because remember, our system won't ignite until I have a minimum of 12% refrigerant in that air. So what some brands are doing is a 6% or 7%. I've heard as even high as 9%, a mixture of refrigerant in that air before it senses a leak in the system and will start mitigation. So everybody's system that I see includes either one sensor. There's some commercial systems that will have 2 or 3 sensors on it, but always then just one mitigation board. Now, the mitigation board is basically just a set of relays. And the idea of the mitigation board is that everything wires back to it, meaning my condenser, my indoor unit, my thermostat. And whenever it senses a refrigerant leak that gets above that minimum percentage of mixture, it's going to turn off any call for heat or any call for cooling and activate the indoor blower on high speed. That way, dispersing that refrigerant mixture into the living space. You go, wait a minute, why the living space? Well, if I'm holding 12% refrigerant in that pan and I disperse that into I don't care if it's even an 800 square foot condo, that 800 square foot condo, I need a great deal of refrigerant to hit that balance of 12% where it becomes flammable. More refrigerant than that system ever even had. If every ounce of it was lost, you're not going to get to 12% in that living space. So anyhow, the idea is that you're dispersing that refrigerant into a space that it never achieves that 12% mixture of refrigerant. This is some of the different sensors that are being used in the industry. The idea is the same. This is actually a heated sensor that measures molecules in the system. It'll actually see the difference between a 7%, 10% mixture of that refrigerant in the airstream itself. Now, traditionally, everything I've seen is that the sensor will be mounted in the evaporator coil section of whatever kind of equipment. That could be a package unit. It'll be mounted on the evaporator pan or near the evaporator pan of that package unit. On a split system, it'll be mounted in the upright position as if that evaporator section, it could be an air handler or a box coil. It'll be mounted in the pan or near the pan if that coil was installed in the upright position. Now, I understand most of our market, it goes horizontal. So what you would do is move that clip or that sensor from the upright pan and just clip it on or move it to near that horizontal drain pan. For the American Standard brand, that's just a clip that sits over the pan that you would just pull it out and snap it into the horizontal pan when you move it to that direction. For American Standard and Duquesne, there's actually a bracket that screws itself to the apex of the coil. Basically where your U-bends are, it fastens there just above the pan. So again, talking about mitigation, brands and who's making that mitigation board is different in between brands, but the idea is very similar. And as a matter of fact, for example, Trane, or American Standard is mounting that mitigation board wherever the evaporator coil is. So if you buy an air handler, it's part of the air handler. If you buy a box coil, the mitigation board is actually mounted to the box coil. You would run your low voltage wires from your thermostat back to that mitigation board, from your indoor unit to that mitigation board, and from your outdoor unit to that mitigation board. Armstrong and Duquesne is actually starting off by selling an R410 coil that is convertible, that you would buy the mitigation board and TXV as a separate component. So when you buy it as a separate component, you can mount it on the 2x4 stud, you can mount it on the side of the cabinet, wherever you want to install it, and then run your low voltage wiring back to there. Eventually, Armstrong and Duquesne will have the board built into the indoor piece of equipment that'll land it there. Looks like we have a question. Are sensors waterproof? Great question. For example, American Standard actually has their sensor down in the pan where it can come in contact with the water. So I would say it would have to be for American Standard. Duquesne and Armstrong are actually mounting their sensor just above the pan. So it would be dry. So maybe theirs are not. So we'll have to see a little more information that as it comes along. Is Goodman putting the sensor in the coil? Michael, I apologize. I don't know. I haven't seen that where they're actually physically mounting their sensor. All right, this is a wiring diagram for a mitigation board. Don't get yourself all wrapped up into the wire and where they go. It'll be a little different by brand that you're installing or what you're working on. The bottom line is for everybody that I've seen on the mitigation board, when it's a package unit, it's pre-wired into the system. There's nothing you need to do with it. That mitigation board, you're just going to land your low voltage terminals or your low voltage wires for operation, and you're good to go. When you've got a split system, everybody's that I've seen, the low voltage wiring always comes back to the mitigation board. So my thermostat comes back to it, my indoor unit comes back to it, and my outdoor unit comes back to that mitigation board. Okay. And then my low voltage wiring for my sensor goes back to that board as well. Oh, all right. So timeline. Let's our timeline. January 1 of 2025. So when they come in to work that morning, which will be New Year's Day, so they're probably not going to come in that day. But really, the last production day of December 31st, 2024, Manufacturers can no longer build HVAC equipment after they close that business at the end of the year. They can no longer build equipment with R410 refrigerant in it. So that's the production date. Now, most manufacturers originally said that they were going to start moving production to R454 about September. Well, every manufacturer that I've seen, except for Daikin, has pushed that date back. They are trying to put it off as long as they can for cost reasons. The new systems will be higher priced, so they're trying to build as much R410 as they possibly can. Now, they're going to actually try to build equipment up to the very last day of the year. Now, that also depends on, how many POs did they get? How much equipment orders did they get, right? We ordered a bunch from our manufacturers, but so did our competitors. So will they all be filled? Only time will tell. Will the manufacturer be able to get all the components they need from their vendors like Copeland or LG? That still is yet to be known, right? But any equipment that is made this year, if it's a split system, meaning there's a line set in between, so I have an indoor component and I have an outdoor component split system, I have a 1-year sell-through date. That means if you wanted to buy a bunch of equipment and stick it in your barn, you're welcome to do so, but you would have to have it sold by the end of next year if it's a split system. Package systems, they decided to give a 3-year sell date. Now that could be a 2-ton little resi unit. That could be a 25-ton, rooftop system. There's a 3-year sell-through for package systems, which means it has to be built before the end of this calendar year. And then you have 3 years to install it. Now, there was some confusion. This is not on my screen, but there was some confusion about service components. Now, I'm not talking about repair parts. Repair parts is your compressor, your TXV, your coils and things like that. All that stuff has to be covered by that manufacturer for whatever that warranty date is. That's a repair component. The terminology they were using was a service component. They're basically, we're talking about an entire outdoor condenser, right? The whole thing, compressor, coil, contactor. The Department of Energy and EPA were considered that a service component. It's not a system. It's only a service component because we're only talking about the outdoor portion. They actually said that the manufacturers can build those indefinitely. Well, it sounds pretty exciting, right? If I can just change out the outdoor unit and keep it R410, why wouldn't I? Well, about 6 weeks ago, the Department of Energy said, well, hold your horses. If you're going to do just a service component, now when I say service component, again, I'm talking about the entire outdoor condenser. If you're going to build that entire outdoor condenser as a replacement component for R410, it has to meet a minimum efficiency. Right? That's where the sticky part comes in. For it to meet that minimum efficiency, it has to be inverter driven, some of the highest technology out there. And really what that did is just price them out of the market. So most of the brands that I've heard from are not going to make that service component for outside. R410. R410 is going away. The good news is, despite everything we learned in our business classes and our economic classes in high school, supply and demand doesn't always mean supply and demand. And I'll explain that in just a second. But R410 is going away. At this time, there is also no drop-in for R410A that reaches that new minimum refrigerant of 700 GWP. So there is no drop-in for R410. Now, will somebody maybe come up with it? Possibly, but it's not there at this time. So R410 is being reduced in the amount of production and the amount of import into the United States. So in 2022, so a couple of years ago, we had a reduction of 10% into the US market. In 2024, so actually almost 10 months ago, we had an additional reduction of 30%. So a total reduction of 40% into our market. Now, I honestly, if you read trade magazines from 12 months ago, they would have said that our 454 would have been $800 a drum by this time of year. Well, it's not there. And matter of fact, it just reduced in price again. And what had happened is there's a great deal of that was imported and is sitting in stockpile. But I can tell you, and I can promise you, as that stockpile reduces, the cost of refrigerant will go up. And again, as we reduce more of it, again in 2029, we reduce another 30% of the amount of refrigerant that's allowed to be imported into the United States, and that will have a reduction of 70%. Now, we don't totally reduce it down to nothing. We're allowed after 2036, 15% of production still brought in. But the bottom line is you're going to need to reclaim your refrigerant and buy it back from your reclaimer. You're going to need to get yourself into that relationship. That won't be your wholesaler. That'll be somebody that's doing business as a reclaimer in your market. Again, usually, in most cases, as the quantity goes down and price goes up. We haven't seen that yet, but it's going to happen. If you have some available cash and you're going to be in this business for the next few years, you may want to buy some additional refrigerant while it's at this low price, because it's going to change very soon. Let me jump into the Q&A and see if I'm up to the stuff here. Well, other manufacturers have a convertible R410 to R454. Let's be clear about convertible. So convertible tells me I can go back and forth. That is not the case, even with the Armstrong and Duquesne line. Now, Armstrong and Duquesne is also owned by Lennox, who are the same people that own ADP. So if Armstrong and Duquesne have it, chances are ADP and Lennox have it as well. Now, here's the rule. You can buy the coil out of the box as an R410 and convert it to R454. But there's stipulations to that. The stipulation is if I, for one day, run that system as an R410 system, I no longer can convert it. Once it has R410 refrigerant in it, Armstrong and Duquesne say that's an R410 coil the rest of its life. And vice versa. If I run R454 refrigerant through it, I cannot convert it back. It doesn't go back and forth once that first shot of refrigerant goes through it. Okay. And again, I haven't heard of other manufacturers besides them doing that. But anyhow, that's the only ones I've heard of. So, all right, I'll give you a moment here to ask any questions if you have any. But that's all I've got for today. Thank you for being with me. And again, in probably mid-November, we'll have an installation A2L class specific to brand. And then around the first of the year, we'll have A2 classes specific to troubleshooting to your brand. Have a great day and be safe. And I'll watch the Q&A for just a few more minutes. We received some Goodman equipment to install, and it was the new refrigerant came through with Dragonfly, but not the sensor. What do I need to do? Oh, I don't know with Goodman. You need a sensor. I assume when you say Dragonfly, I assume that's their mitigation control. You will need a sensor. That system will not operate, and you don't want to install it without a mitigation sensor. It may be clipped to the coil inside, so look. Oh, you're welcome, Matthew. I hope you're doing well. I miss you, my friend. One more just popped in a second. Is it true that R32 will be replaced within the next few years? Stephen, that's not guaranteed yet. Matter of fact, there's 5 states that actually want to replace R454 and R32 now already. The federal government shut those 5 states down. But yes, there is a possibility that R32 could go away sooner than the 10 years, even R454. That hasn't been decided yet. So I wouldn't use that as a selling point. Right now, R32 and R454 are on the docket both for the next 10 years. If you want to keep up on the refrigerant market, there's a lot of people called like ESCO. You can follow them on Facebook or LinkedIn. It's ESCO. They're the national educators for HVAC, AHRI, ASHRAE. A lot of those people have lots and lots of training all the time on LinkedIn and on Facebook that you can watch how the industry is changing. It's changing fast. We've got injection compressors coming out. Matter of fact, Fujitsu just introduced them. So they're, matter of fact, Trane, American Standard, Duquesne, Armstrong are working with them as well. They're low temperature heat pump systems. Can you please mail a copy of it? Jason, your territory manager has access to a copy. Please reach out to your territory manager if you want to record a copy of the PowerPoint. So I want to have this clear. If we replace the condenser outside, we need to replace the indoor unit. Yes, Gilberto, if you're going to a new refrigerant, the R454 or R32 refrigerant, both components, indoor and outdoor, have to be rated with that new refrigerant. You cannot leave the existing evaporator coil. So if it's an air handler, you'll have to change the whole air handler. If it's a furnace, you can leave the existing furnace behind and just change the evaporator. But the refrigerant system does have to be that new refrigerant. All right, you guys and ladies, stay blessed and have a wonderful day.